Okay, so we're going to try another one of these videos where we do like an impromptu chat. I'm here with my colleague Daniel, who's also in the networking team, but over in the US. And Daniel watched the previous video, which was on combining routing intent with Azure VMware Solutions, where I talked to Dennis, who's more on the AVS side. And he watched it and gave me some feedback, was like, hey, we do this kind of trick sometimes, and we got some feedback, and me and Daniel got chatting and said, well, maybe we can revisit this topic. And Daniel's going to share some of his knowledge. And maybe you want to start off, Daniel, just explaining why you work a lot with AVS customers who may not be able to use global reach, right?
Correct. Thanks, Adam, for the introduction. Yes, I do a lot of work with Latin America customers where they have the lack of the global reach feature. And a lot of them, they use a secure virtual hub with routing intent in order to make the transit between AVS and on-premises. And when I watched your video, I do have some exposure for few use cases that I want to share with you on this video that I use with them, like route summarization and also show you a few alternatives depending on the customer requirements and change that we may need to do depending on the customers, because not all of them are ready to receive those RC 1918s from Secure Virtual Hub. And that's why we're going to go over a few tips here and how to overcome those.
Okay. So yeah, I mean, definitely check out the previous video to get your bearings, but just very quickly in this diagram, in purple, we've got the vWAN hub in the middle. We've got an ExpressRoute circuit on the left that's connected in, which goes to on-prem. That's my on-prem range. And we'll get into some of these outputs of routing tables in a second. On the right-hand side, the same ExpressRoute gateway inside of the same vWAN hub is connected over here to an Azure VMware Solutions SDDC, and that's got this range 1057. I think it's a /21 configured on this SDDC. You need a minimum /22 normally. And as we talked about in the previous video, you enable routing intent. You get Azure support to enable the toggle that sort of allows this ExpressRoute Transit, and then that causes these summary routes to start leaking towards on-prem, and that's where some customers might be okay with that behavior, and some customers may want a different behavior, which is where your feedback was, right? So maybe we can sort of zoom in on this route table, and that can sort of help us talk about it a little bit, because here I've got highlighted in black and yellow. That's what the customer would get from Microsoft, right, on their edge equipment. And maybe you want to talk about why that wouldn't be acceptable for some customers.
Yes, one of the main reasons why this not be acceptable is first customer, not just one, but several customers that I had experience with this type of transit. They already advertise the RC 1918 from on-premises. Some of them, they do it because either they want to do the summary to attract all the private routes to on-premises, others for security reason, because they want a black hole and make sure all private traffic terminates in on-premises in a firewall. And that's why we do have this challenge because the customer is already advertising. And because we cannot change this behavior on the secure virtual hub, which today is by design, when you turn on the routing intent in the scenario for ExpressRoute to ExpressRoute Transit, secure virtual hub is going to advertise RC 1918. So, and that's my recommendation is before you recommending the solution, you have to do a step back and try to understand first what the customers is advertising from the on-premises. And that's the first thing usually I do. Let me understand first what you are advertising. And based on what I see, I start to discuss with the customer what are the alternatives that we can do. So because we cannot change this behavior on the secure virtual hub side, one thing that we recommend to the customers to do is, okay, before we turn on the secure virtual hub with a routing intent, I need you to break down in your side those prefixes, the three prefixes that we have in RFC 1918 into halves, which means I need to break down the 10/8 into 4/9s, the 172 into 13s, and the 192.168.16 into 17s. So that's the first thing to do it. Then we can, based on the customer requirement, we can keep them as as a high priority in terms of private traffic coming from Azure, and we're still able to inject those summary routes from the virtual hub, and the customer can keep attracting the private traffic.
I think we allude to that, don't we, in the virtual WAN routing intent doc? What that
we
bit
do,
you said.
we do. Yeah, if you go to routing considerations,
That's saying the same thing. If a customer was already advertising those routes, like you said, break them down. So I suppose there's two different categories of customer here, isn't there? One that is already advertising those routes to Azure, and maybe there's a customer that's not advertising them to Azure, but doesn't actually want to let them leak into their network any further than the edge.
that's correct. That's correct.
Okay, I'll jump back to the diagram now.
Yeah.
Okay, so what's the possible fix then? I mean, I suppose just while we're here, we can highlight that. You know, I've got the routing table here from the Azure firewall in the VWAN hub, and we can see all of the prefixes leaking in from AVS as AVS is advertising them, right? There's /24, /25. These are like all the management subnets and the segments from AVS. But as we said in the previous video, they're not passed on as is, right? And I suppose what you're advocating here is we can take a summary that encompasses all of the orange.
That's correct. So in this case, because AVS always advertise those more specific routes, in order to make sure we can send the traffic specifically for AVS for on-premises, so we need to ensure that we can add the forward/21 and the private prefixes inside the virtual hub. In this case, inside the secure virtual hub, where you have the private prefixes. When you had that private prefixes as forward/21, the behavior from secure virtual hub is going to start to advertise that summary route to all the ExpressRoute connections. In this case, it's not going to affect AVS because AVS has already the more specific routes. And the benefit here is on-premises is going to see the forward/21 and is going to consume that forward/21 in order to send the traffic specifically for the AVS environment.
Okay. Okay, maybe we should make that change, show people where it is, and then jump on the circuit again and look at the impact of that. So I'll jump to my VWAN hub, and I'm going to need to go into Azure Firewall Manager, right?
And private traffic prefixes, and just add the AVS summary route.
I think that was the right prefix, right? 1057.00/21. Okay, and then just save that, yeah? Is there any considerations here around saving it? Is it going to be impactful? Should I do this during a change window, or can I just click save?
Technically, there is no change other than if you're not flipping any one of those configurations below for internet traffic, there is no impact in anything for virtual, and it's just going to inject that route in the table and start to advertise them to the ExpressRoute connections. Okay, we're done.
Yeah, we're back. So that operation completed. So we've got that prefix in there. So in theory now, if I recheck the route table on this ExpressRoute circuit, as well as those highlighted summary routes, we should be getting that /21 we configured. And then we could talk about why that's good. So let's go to the ExpressRoute circuit, and I'll refresh this. So you can see I copied this into the whiteboard earlier and sort of trimmed out some of the bits which were not relevant, but I'll do a refresh here. Hopefully we see that /21. Okay, yep, so 1057.00/21, as you said. So that will be getting advertised to the customers on-prem now. And again, we have no other 10.57 routes there.
Yeah, and like I said in the beginning, so some customers that I've worked with, they had already the advertisement RFC 1918. They need to keep that. And that way, what they can do in this scenario is add the summary of the AVS to the private prefixes. And now they can block the RFC 1918 arriving at the site and only allow the forward/21 from the AVS to go inside the network. And with that, all the traffic related to AVS is going to go towards the Azure Secure Virtual Hub and properly forwarded to the AVS environment.
Makes sense. We've kind of got all the benefits of sort of inserting the Azure firewall in that flow, and even enabling this flow for the customers that can't use global reach. We're working around this RFC 1918 default behavior, and as long as the on-prem network team are comfortable filtering that out, we effectively get the route that the customer actually wants, which is the AVS endpoint. That makes a lot of sense. Maybe just one thing that's sprang to my head there would be, maybe we can explain why in the private traffic prefixes, we can't just come in and configure the exact prefixes, right, that AVS is advertising, because that's going to break things, isn't it?
Correct. One behavior is what's going to happen is if the virtual WAN detects that the customer is advertising either RFC 1918, in this case also it is not going to inject, right? So if you have like a conflict that the route is already injected in the ExpressRoute, in this case, even if I add those more specific routes from AVS side in the private prefixes, we're not going to have the behavior of the re-injecting them back to the same ExpressRoute, but also to all ExpressRoutes. Just keep in mind, because it's going to detect that one of the ExpressRoute circuits is injecting, and then it's not going to inject that to the other ExpressRoute as well. So this is kind of a mechanism, I believe, that's for protection to allow that virtual WAN is not going to override any prefixes that are advertised by the other side, which in the case is AVS or either the customer.
Okay, makes sense. Well, I think that was a useful addition. I mean, it's definitely one of the ideas of putting this content out is to get feedback like the feedback you gave, like, oh, hang on, by the way, this works also with customers. So maybe there'll be more information we can share in the future. So yeah, thanks for sharing that. Anything else you wanted to talk about?
Yeah, I just want to highlight because you may have a question. Okay, you mentioned that if I already advertise the RFC 1918 from on-premise, for example, and VUN is not going to inject RFC 1918, the question would be why I just not allow that to happen by design. The issue with that is if for some reason your connectivity between your ExpressRoute circuit and your on-premises goes down, you stop the advertisement, then the Secure Virtual Hub is going to inject the RFC 1918. When your circuit is back and try to inject the same RFC 1918, is not going to get injected, which means always the first one that injects wins, so that's why I told you guys that Secure Virtual WAN is not going to inject if it's already detected. It's not really a good practice to leave that conflicting. If you really need the on-premises to always win through RFC 1918, the recommendation is to break down into halves the RFC 1918 in order to always ensure when your circuit is back, is going to always inject the RFC 1918 in a more specific prefix. Make sense?
Yeah, so for those customers that already advertise in the summaries, split it up, and then you can safely take in the summaries as well as the /21 if you want that. For those customers that are not advertising the summaries and they can obviously receive them safely, we've talked about the benefit of getting that /21 or a /22 if you're using the minimum on AVS. Great. Thanks for your time, Daniel.
Thanks for having me.